In this video, I'm going to finally introduce the standard equation of an ellipse with an example. I think an example is the best way to kind of see how the equation functions. Okay, so standard ellipse equation I will list here, but first I like to kind of summarize it by saying it looks, there we go, basically it's squared fraction plus squared fraction equals 1. Okay, and so you'll kind of see that here. So the standard ellipse equation is an x squared fraction plus a y squared fraction equals 1. And then you've got denominators down here. Now, I like to just remember it this way, but if you want to go further, you'll have a number, of course, in the denominators of these fractions. The denominator of the x fraction is the horizontal distance squared, and the number under the y fraction is always the vertical distance squared. Notice everything here is squared. Is squared. Okay. Now also, when you think of x in a graph, you should think horizontal. So the number under the x fraction is the horizontal distance, and the number under the y fraction is the vertical distance. Okay, squared, of course. All right, and that's true. Now, those two distances are also a and b, and so we'll kind of see that the a comes from the bigger denominator, because remember a is the bigger number. B comes from the smaller denominator, and you could then use your a and b that you've determined to calculate c. Okay, so this is the standard ellipse equation, the summary of it. Now let's work through it with an actual example to see how these things work. Okay? Graph the equation and list all the parts of the conic section. And so, in this case, the conic section we're going to be working with is an ellipse. So let's say we have x plus 4 squared over 25 plus y squared over 16 equals 1. And of course this is in standard form. It's the standard equation. So the first thing we need to do is find the center of this ellipse. And the center comes from the x and the y that's squared, okay? So the center comes from the values that make those squared parts equal 0. So I take my x plus 4, set it equal to 0, and I can see that x is negative 4. And then here it's y squared, so y equals 0. I don't have to solve that, it's already solved for y. So my center is the ordered pair negative 4, 0. The coordinates for the center, one more time, are the x and y values that make the x and y in the equation, x and y squared parts in the equation, equal 0. Okay? So in this case, makes numerators 0. Alright, so that's my center. Let's graph as we go here. I think that's the best approach to this, because if we can visualize it, it's much easier to list the parts. So the center is at negative 4, 0. So that's my center. Then I need to measure up, down, left, and right. And so 25 is going to give me my horizontal distance. So my horizontal distance, that's this number squared. So to find my horizontal distance, I have to take the square root of 25, which is 5. So I go 5 units left and 5 units right. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Remember, everything's measured from the center. My vertical distance comes from the denominator of the y fraction, which is 16. So the square root of 16 is 4. So I go back to my center, and I go up 4 and down 4. So 1, 2, 3, 4, and 1, 2, 3, 4. And now I can kind of see my ellipse taking shape. This ellipse is a horizontal ellipse because that's the longer axis, okay? So what that tells me is that this distance here, one of these is A and one of these is B, okay? The bigger one is A, so A is my 5 distance and B is my 4 distance. So this is my A distance, this is my B distance. Alright? And so once I have those, I can find my C distance. Of course, my horizontal distance is measured left and right, and my vertical distance is measured up and down. And A and C are always measured the same way. They're always on the major axis. So C will be measured up and down, or sorry, left and right, just like A is. So C squared equals A squared minus B squared for an ellipse. Now, the equation of an ellipse always has a plus here, and the CAB equation always has a minus here. Okay, they're always opposites of each other. I'll just point that out one time in case it helps you remember. So I can see that C squared equals A squared, so 5 squared, minus B squared. So C squared equals 25 minus 16, which is 9. If I take the square root, I can see that C is 3, and as I said before, that's measured left and right because A is also measured left and right. So I'll go 3 units, 1, 2, 3, and I'll go 3 units left, 1, 2, 3, and those are going to be my foci. Okay, so let's sort of see what we have here. These guys out here, 5 units from my center, those are my vertices. So my vertices are those two ordered pairs. This guy is -9, 0, and this guy is 1, 0. So those are the points in yellow. The points above and below, those are the endpoints of my minor axis. So my minor axis endpoints, this guy here is -4, +4. And this guy down here is -4, -4. Okay? And these guys right here are my foci. Those are my C distance from my center. So the one on the left is -7, 0. And the one on the right is -1, 0. Okay? Finally, my major axis length, sorry I'm running out of space here, is from vertex to vertex. So from -9 to +1, that's a distance of 10. Or you could think it's 5 2 times because A was 5, remember? My minor axis length is my shorter length across the ellipse, so from top to bottom. From -4 to 4, that's 8. Or you could think it's 2 4s because B was 4. Alright, now we just have to graph the actual curve. And I'll do that a little thicker because once again this is kind of crowded. So my ellipse wraps around my foci and passes through my vertices and the endpoints of my minor axis. I'm sorry the graph isn't perfect. But that is the ellipse that's described by this equation. Center comes from the numerators. My distances come from my denominators. Those are A and B. The bigger one's A, the smaller one's B. The one that's with X is horizontal. The one that's with Y is vertical. I use those then along with this equation to calculate C, and C is measured in the same direction as A, in this case left and right. Once I've got that, that's all I need to finish up the problem. And that's how you work with the standard equation of an ellipse. Now sometimes you're given equations that don't look like they're in standard form. Let me give you an example. What if I have 16 times x plus 4 squared plus 25 y squared equals 400? This is not in standard form. The key is to have 1 on the right side, the number 1. The way to do that is to divide both sides by 400. And now these two fractions on the left reduce. 16 goes into 400 25 times, leaving a 25 on the bottom. 25 goes into 400 16 times, leaving a 16 on the bottom. 400 divided by 400 is just 1. So you end up with x plus 4 squared plus, over 25 plus y squared over 16 equals 1. And now that is in standard form. Okay, so the key to this is getting that 1 on the right side. Now sometimes there's some completing the square involved to create things like x plus 4 squared. I'll reserve that for a different video since this video is already running kind of long. But I wanted to show you that sometimes it's very close to standard form even though it doesn't look like it. You just have to divide to get a 1 on the right side. And then again you get your center, your distances, use those to find the C distance, and then you can finish the problem.